Are you looking to increase your design skills and productivity? From sketching, surfacing, assemblies, and everything in between, our books have you covered. Purchase a paperback or PDF version in our store today.
Hello everyone, my name is Steve Samuel from Design Visionaries, and today I have a project where I want to make sure I can account for bouncing and rolling of objects. And so I have this assembly with these spherical bodies that are going to be thrust down into this little trough by gravity. And gravity is going to pull them through the little tube, and they're going to fall into the bucket here. So in order to proceed, I go to the motion package. This is different than the animation package because the motion package, the full-on motion package, has the ability to emulate the bouncing of bodies, the gravity, all of that. And so I go into new simulation and I create the simulation. And when I create a simulation, it's a little bit similar to the animation package in that I've got to define the rigid bodies. So we're going to do a simulation 3D motion, and what you'll see me do is create rigid bodies and then create the joints, if you will, in between them, and then go on very similar to the way we have learned how to do the regular animation package, okay? So, first off, here is the place where you're starting to define the rigid bodies, if you will. So, these are components, but I can say select object, and I select it as an object. And then the very first thing I do is click on Apply Automatic Values. So this looks at the mass properties. It looks at what it's made of. In this case, these are assumed to be steel. And I can name that ball 1. I think I'll put an underscore there. Ball 1. And I'm going to say Apply. And like I said, I'm going to Motion Body, and I'm selecting this one now. I have to click on Select Object, select the object, hit this little button that calculates the mass properties, and you can give it a name. Ball underscore 2. There's that. And it's you can see that it labels those things. And I really shouldn't have gotten out, because what I need to do now is select this whole piece of geometry, and that's going to be called the tube. Apply, and finally the select object, the bucket. Okay, so that's all done. Great. Now, very similar to the animation package, I'm going to define the joints, and there is a fixed joint, and so I go to fixed, and the the tube is fixed. It wants an origin of some sort, and it wants a vector. So I'm going to say apply to that. This is going to be fixed, and say apply. And it's sitting there and doing that. And I'm also going to do another fixed joint. There's fixed. Select the motion body. There's that. And we're going to do a origin. Specify a vector. Not that it matters because it's fixed. And I'm going to call this fixed 2. and say OK. And we're going to do a rename on this one, because it's really important to keep track of these things. Okay, so now that we have two of the essential joints that we want, now the next thing we're going to do is we're going to make a contact, a 3D contact. And what we're trying to do here is make sure that this will contact that when it falls in. And we have a damping. Let's see, we have a damping coefficient. Material damping, here it is. And if it's something that's bouncing, the damping is very low. So we're going to give it 1 pound force second per inch. So that's a material damping of 1. So that's in between those two. And this is going to be ball to tube. It should be ball 1 to tube. Ball 1 to tube. Enter. Apply that. And we're going to make another one. From there, there's the action body, and here's the base body. And we're going to have material damping again. And this is going to be called ball 2 to tube. And apply. And when ball 1 goes through the tube, it's going to end up in this little bucket. So I have to make a contact between those two. And material damping of 1. This is ball 1 to bucket. Apply that. And finally, we need this one here. And to this one here. And this is ball 2. Ball 2 to bucket. Good. And so then we say OK. All right, so we've got fixed, contact, 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 contact. And we are ready to edit the, we're ready to create a solution, Now, when we create a solution, we have the ability to impose a gravitational force and direction. And we're also able to define the amount of time that we're going to be looking at this system. And I think if we look at it for 20 seconds right there, we're good. And we get to specify the interval. I think 0.01 will be fine, and we'll see what happens. And we're not including a static analysis of any sort. We just want to see this kinematic thing. We just want to see it work. And the gravity is in inches per second squared. And I am just going to slow that down. So it's 150 inches per second squared. So we're on Mars, I guess, somewhere. And this is called solution 1. And I'm going to say OK to that. So now we have a solution. Now we have to solve that solution. So we hit the solve button. And this is going to take a minute or two because it's doing a lot of iterations, a lot of calculations. And we might see that when it bounces too high. I might have to edit the damping or do a number of things because, you never know. But here we go. We're not getting any errors. And so now, having done that, we can go into the analysis and we can check out the animation. So here's the animation player. I'm going to cross my fingers a little bit and hit the play button and see what happens. Oh! So now, what happened was, when I specified the gravity, I didn't get to the point where I was selecting the vector. So that was a big mistake on my part. So I'm going to edit that solution. Let's do, Right here we have to edit. Hold on here. No, down here. Silly me. Right there. We've got to edit this. It's my little solution attributes. Got to go into solution attributes. And what I didn't do correctly was specify I need a vector on that gravity for minus y. So there, the gravity is pointing downward. Okay, and now I've got to solve it again. So we've got to go back home and we're going to say solve. And we wait for a moment or two. Not very long because there's not a lot of moving parts in this, but we are looking at it for 20 seconds with 0.01 increments. So it's going and going and going. In the meantime, I guess when I do the animation, I'm going to not show those little blue indicators. And in order to do that, I'm going to say Control W, and I'm going to turn off, I'm going to hide all, and then I'm going to just bring back the bodies. So there. With this little coordinate system, I don't want to see that, so hit the W key. Great. And now I'm going to go into the results, and I'm going to do the play. First, there's a device that is very, very useful in CAD. I take this hand right here and I put it up like this, and I take the other one and I put it against it and I go like this. You'll find that device works in many situations for many CAD programs. And let's hit play and see what happens. Hit play, it bounces. Oh, one of them rolls out, one of them goes down and down and down. And let's see if it makes, oh, it overshot the bucket. So that is almost a success. Almost a success. So in order to make it succeed, I'm going to return to the model here. I'm going to go to the solution, and I'm going to edit the solution attributes, and I'm going to make the gravity a little bit less severe. So I'm actually a lot less severe. I'm going to make it 80. And say OK. So I've changed the gravity, and now I'm going to solve the solution one more time. And this ought to do it. I thought that was pretty funny, though, that one of them bounced out and one of them missed the bucket and the other one missed the bucket. So we wait a little longer, but it's really pretty cool that the balls went around in this trough. What I forgot to do is turn on the friction. That's what I needed to do. I want the friction so that when they roll, it's a little bit more severe. So I'm not even going to play this one. I'm just going to go back to the solution here. Solution. And no, the friction is in the contact. So let's go to the ball to tube contact and edit that. And we're going to turn on the friction, Coulomb friction on. Now we have a static coefficient of friction and a dynamic coefficient. And I'm going to turn it up pretty high, 0.6. So there's the friction on that ball. Say OK. And on this one, I'm going to edit that one as well and turn on the Coulomb friction. And this one's going to be a little more slippery, but at least it has something. And then when it gets in the bucket, I want it to roll around in the bucket. So I'm going to edit that one, turn that on. I'll just use the default. And this one too. And turn this one on. And what I could do is make the balls contact each other as well. So I think I'll do that. So that means if they ever get in the bucket together and they hit each other, it'll actually be OK. So we got material damping of 1 on that one as well. Say OK. All right, and then I'm going to Control W and hide everything and bring back all the bodies. And now, finally, I'm going to cross my fingers one more time. And I'm going to go and solve that whole thing. And this will take even longer because now it's got the other ball-to-ball contact to resolve. So there's just a lot more calculation plus the friction. So it makes sense that this will take a lot longer. Again, we're viewing it for 20 seconds. We could probably cut that down, but we'll see how long it takes for these balls to roll around and go through that tube. And hopefully the ball that bounced out last time will not bounce out. It's an incredibly powerful tool that allows you to truly calculate what happens when real things contact each other. It has the friction, it has the good way of figuring out what happens when they meet. The animation in this program is really great, but it's not a simulation. It doesn't take all of this into account. And it's important to do the mass properties. As you may recall, when I did the mass properties of the rigid bodies and the balls, I was just able to click on that little button that automatically calculates it for you. But you can also assert mass property. If you have some rigid body that, let's say, is it's some representation that you get from like McMaster Carr or someplace like that, where it's the outside is modeled but nothing else, then you might want to assert the different mass properties. So here's all the steps, and as you can see, there's no warnings or anything. And now, the moment of truth, we go to the analysis and the animation viewer, and we hit the play. And now, as you can see, they're bouncing the correct way. They're rolling through the tube. The gravity is a lot less, so they won't be coming out of there as fast. And they do hit the bucket, and they do contact each other. And that is a great success. So again, my name is Steve Samuel. Thank you very much for your viewership. I really appreciate it. Our subscribers are growing now because a lot of people are finding these videos extremely useful. And we are having a lot of success answering questions. You can reach us at info@designviz.com, and you can literally request something that you've always wanted to know about or see. Also, there's a full line of books about how to do all of this on designviz.com. If you just go to the website and you click on books, we've published a lot about this for people. The books are not that expensive. They're written for engineers who really need to get something done quickly. There's not a lot of fluff, and I've taken a lot of pride to do it. So thanks again for your viewership. I really appreciate it. Please like and subscribe, and I will see you on the next video.